For the second half of this section, we talk about differentials. So we have a blue curve, that's our original function, a gold point, which is a known value on the original function, and then the red tangent line. And we're going to talk about some notation points here. So a differential is something that allows us to estimate how much a function changes when we make a small change in the input value. So our input is x. Let's say we changed the input value just a bit. We call that dx. And we can see how much that changes on our linear approximation by measuring how much the change in y is from the gold point to the red point. We'll call that dy. That's our differential. That comes from the derivative of our function multiplied to the dx, the change in the input value. Now this is not the actual change in the function, this is how we're estimating our change in the function. The actual change in x would be called delta x. The actual change in y would be called delta y. That actual change comes from calculating our function at the new point, which is at a plus some dx, subtract the old point. So we're measuring change by taking the new value, subtracting the old value. The approximate change is given using L of x, so that's our dy. That comes from our function L at a plus dx minus the original function a. And if we say that dx is very small, so notice that if dx is very small, the red and the blue points are close together, our delta y is approximately equal to this dy differential. Let's take a look at how we can use this in an application. So here we're looking at a function y, which is defined as x squared plus 2x. We're going to compute the delta y, that's the actual change, and the approximate change, dy, starting at x equals 3 and changing our input by 0.01. So our delta y, that's going to come from our function evaluated at 3 plus our delta x, which is 0.1, minus our function at 3. So we're really looking at f at 3.1 minus f at 3. We can plug each of these into our function and calculate. Simplify this out with a calculator. I get 15.81 for the function at 3.1 minus 15 for the function at 3 for a final change of 0.81. So the actual change in y is 0.81. Let's compute the differential dy. This is going to involve the derivative at 3 times our change in x, which is 0.1. So we need the derivative. The derivative of our function y comes out to be 2x plus 2 if we evaluate that at 3. we get 6 plus 2, or 8. So we go back to our dy, plug in what we found. We get dy equals 8, that's the derivative at 3, times 0.1, which comes out to be 0.8. So the actual change was 0.81. The approximate change was 0.8. So for any function, we can now measure the actual change for a small change in the input. We can also measure the approximate change for a small change in the input. Most of the time, we'll use an approximate change because it's much easier to calculate. Notice this calculation involved a derivative, but that wasn't that difficult. And then from there, it was just one product. Whereas with the actual change, we had to evaluate the function at 2 different points to be able to find out how much the function changed, and we really didn't gain that much extra information by doing this the long way. All right, that's it for section 4.2. So I'll post some practice problems. You can take a crack at them. Be sure to come to office hours if you have any questions, or post comments in the video, or start a discussion in the class if you want to talk more on either of these topics.